The thermoelectric effect. First of all, we must see the definition. Conversion of temperature difference into electrical voltage and vice versa. What is that vice versa? If electrical voltage is applied, and by applying this electrical voltage we can produce the temperature differences across the ends of the conductor. Okay, once again I repeat, this is the definition for thermoelectric effect. Conservation of temperature difference into electrical voltage and vice versa is known as thermoelectric effect. A thermoelectric electric device generate voltage when there is a temperature difference on each side. If a voltage is applied, it generates a temperature difference. Okay, thermoelectric device generates voltage when there is a temperature difference on the each side. Okay, temperature difference, if you are maintaining, a thermoelectric device generate the voltage. If you are applying the voltage across that two ends, it generates the temperature differences. So that is nothing but the thermoelectric effect. Next we are going to see a Seebeck effect. What is that Seebeck effect? Seebeck discovered that in a closed circuit consisting of two dissimilar metals, when the junctions are maintained at different temperatures, an EMF is developed. So he considered there are two dissimilar metals, two different metals he have considered, and when we make a junction, so both will be connected. Okay, and maintaining two different temperatures, an EMF is developed across the junctions. The current that flows due to the EMF developed is called thermoelectric current. So there is a current is flows due to EMF developed is called thermoelectric current. The two dissimilar metals connected to form two junctions is known as thermocouple. So what is thermocouple? Two dissimilar metals connected to form two junction is known as thermocouple. Due to this thermocouple, if you are maintaining, if the current is flows through due to the EMF developed is called thermoelectric current. If the hot and cold junctions are interchanged, suppose if the position of the hot and cold junctions is interchanged, the direction of current also reversed. Okay, the flow of current will be reversed, and this effect is called a reversible effect. This effect, Seebeck effect, is called a reversible effect. Now the magnitude of the EMF developed in the thermocouple depends on two factors. One is the nature of the metals forming the couple. Second one, the temperature difference between the junctions. See here they have taken two conductors, one is a copper and another one is a iron. So between these two we have maintained two different temperatures, one is a cold and another side is a hot junction, because we are giving the heat energy continuously. And in between this we have connected one sensitive galvanometer. By maintaining a different temperatures, the current is passes from iron to copper in the cold junction. At the hot junction the current is passes from copper to iron. Okay, so same way, suppose if you are maintaining like this between the hot junction and the cold junction, for example we are maintaining between metal A and B, we have considered a two metal, a different dissimilar metal we have considered, and between this junction we have applied the potential. When you are applying a potential, one junction it may be a hot junction, the other junction it may be a cold junction. Okay, right. Now what will be the applications of Seebeck effect? So define or write a short note on Seebeck effect. You have to write what we have discussed earlier. So now this is nothing but another one important 2 mark question. Sometime you may expect a 3 mark question. Applications of Seebeck effect. Seebeck effect is used in thermoelectric generators. Okay, and these generators are used in power plant to convert waste heat into electricity. So in power plant, some of the heat energy will be wasted because all the energy will not be used well. So some will be wasted, and those wasted heat energy will be once again is converted into electrical energy. So electricity, it will be converted into electricity. For that purpose it will be using. Okay, and second one, this effect is utilized in automobiles as automotive thermoelectric generators for increasing fuel efficiency. Okay, it increase the fuel efficiency. Earlier all the motors will be flowing, okay, that petrol will be flowing very fast, but now BF4 like this we have a new model. Okay, so all that it will be injecting, so it will be drop by drop the fuels will be coming out, and it will be a nice a technology which is introduced in the automobiles. And next, Seebeck effect is used in thermocouples and thermophiles to measure the temperature difference between two objects. Okay, so these are the applications. And next, Peltier effect. What is that Peltier effect? In 1834, Peltier discovered that when an electric current is passed through a circuit of a thermocouple, heat is evolved at one junction and observed at the other junction, and this is known as Peltier effect. If they are asked in 2 mark question, you have to write this statement. Okay, so what is called Peltier effect? Write a short note on Peltier effect means you have to write this statement and draw this diagram. So here there are two dissimilar metal we have taken. One is a copper and another one is a iron, and between these they have applied the potential. By applying a potential, what happens? The current will be passes from positive terminal to the negative terminal in anti-clockwise direction. So while passing through, when the current is passes from copper to iron, at the junction it will be a cold junction. The other side, the current will be passes from iron to copper, at that junction it become heated up, okay, a hot junction. Suppose if you reverse the battery, the current, and here there is a small mistake in the diagram. When the current is passes in the second diagram, if the current is passes from copper to iron, B become cold, and iron to copper, the current is passes at the junction A, and this junction it become hot. Okay, so this you can keep in your mind. In the copper iron thermocouple, the junction A and B are maintained at the same temperature. Let a current from a battery flow through the thermocouple at the junction A, where the current flows from copper to iron. Heat is observed and the junction it become cold. At the junction B, where the current flows from iron to copper, heat is liberated and it is become hot. When the direction of current is reversed, A is heated and B become cold. Okay, and this is also a reversible, the Peltier effect also a reversible process. Okay, a reversible we called. Next, Thomson effect. Thomson showed that if 2 points in the conductor are at different temperatures, the density of electron at these points will differ, and as a result the potential difference is created between these points. So this is nothing but Thomson effect statement. So now we have to see Thomson effect is also a reversible. If current is passed through a copper bar AB, which is heated at the middle point C, the point C will be at heated or higher potential, because that point C it become very hot. Okay, so it attains the higher potential, and this indicates that the heat is observed along AC and evolved along CB of the conductor as shown in figure A. Thus heat is transferred due to current flow in the direction of the current, and this is called a positive Thomson effect. Okay, heat is transferred due to current flow in the direction of current. Okay, and the same way some of the metals it acquires, and those metals also will be accept the positive Thomson effect. For example, silver, zinc, then cadmium. When the copper bar is replaced by iron bar, heat is evolved along CA and observed along BC. Thus heat is transferred due to the current flow in the direction opposite to the direction of current. Okay, so now you can see the diagram. So this is the first diagram, which explain the positive Thomson effect, and the second diagram it explain the negative Thomson effect. So first we are going to see the positive Thomson effect, and we have considered a copper bar. So now at the midpoint, and it will be denoted AB, and C is the midpoint of the copper bar, and at the midpoint we are applying the heat energy, and due to this heat energy, point C will attain the maximum potential. Okay, now the current will be passes from A to B. Now the point A, it attains a very low potential because it become very cold, and from C to B heat is evolved, which means the potential will be gone increasing. Now the potential will be varying from A to C, so from minimum to maximum, and again it will be varying from C to B because C it become very hot point, so high potential will be executed. Compared to C, B it become cold. Okay, and because of that it heat is evolved along CB, and heat is absorbed along AC. So if any of the metal is execute this type of phenomena or property, then it's said to be a positive Thomson effect. And negative Thomson effect, now here instead of copper they have taken the iron bar, and the current also will be passes from A to B, and we have named AB both corner, and midpoint will be denoted as C. When we are giving the heat energy, and at C you are experiencing very low potential because AC the heat will be evolved along the direction of the current. AC the heat will be evolved, and CB the heat is absorbed, and because of that the point C will attain the low potential. So which are the element or which are the metals it accept this type of phenomena, then those metals are said to be negative Thomson effect materials, and the example is platinum, nickel, cobalt and mercury. Thank you.